Hello, everyone. I am welcoming back Professor Troy Ada from Lehigh University. And we should have a pretty interesting discussion today because this is the question that comes up all the time, especially with new applicants. And in general, what is the difference between data analytics and fintech? So, Troy, please go ahead and introduce yourself a little bit to give you a bit of background where, why is it that we should be listening to you? And and then tell us what your views are.
Sure. So to put it succinctly, I'm a former finance professor that has sort of reverse engineered themselves into a data scientist. I was the banking risk management professor for the MBA students at the University of Michigan. And then I went into administration. And then I said, hey, this data science stuff seems cool. So I've been doing that for about the past 10 years. Just like you, Patrick, I often get asked, what's the difference between fintech and data analytics and data science and business analytics? First, I think it's safe to say that data science is probably sort of the umbrella term for both fintech and business analytics. And data science was sort of in use first. And a lot of times you'll find data science programs such as majors for undergrads or master's programs that wind up doing business analytics and or fintech. So let's talk about what the difference between business analytics and fintech is. Now, this is just my opinion, but over time, what I've come to realize is that if you take the term business analytics and think about it, it involves either calculating a metric or doing some analysis or creating a visualization, but all of it with a goal that a human's going to look at it and make a decision off of it. So business analytics is basically for better decision-making by humans. Fintech, on the other hand, operationalizes activities that we allow computers to either do on behalf of humans or in lieu of humans. Doesn't matter if you're talking about chatbots or if you're talking about AI facilitated portfolio trading, if you're talking about micro lending. If you think about the things that fintech does, you're basically talking about things that either happen too quickly for humans to react to, are too large, if you will. If you think about micro lending, the use of bots, if you will, to track day to day exactly what's in the company's accounts and how many sales they've got and so forth, allows us to make much more informed decisions about the lending process than a human that just looks at even quarterly statements could do. So in a sense, I would say that analytics is designed to create something that humans look at to make decisions, where with fintech, we're actually getting close to, remember that movie Terminator and Cyberdyne, where we basically let the machines decide when they were going to take activities? Well, if anything, I think fintech is, and I mean that in a jovial manner, but fintech is exactly that. We're enabling computers to act on our behalf.
So where is the action right now in terms of the interest, the future, the interest? Is it in data analytics or is it in fintech? What are you seeing?
I think that, well, if you go back to the late 90s and early 2000s, analytics really got started because of the regulatory environment of banking. And all of a sudden, international banks were being told, you have to track these rather precise statistics, you have to track them often, and then you basically have to make sure that you don't go past certain limits. So there we saw analytics sort of got its start in finance. And over time, the ability to keep track of numbers, the cost effectiveness of keeping track of numbers and so forth, facilitated or increased, if you will, by the concerns about supply chain management in the COVID and post-COVID eras, means that analytics has sort of spread out to non-financial firms. Now, fintech, right, the very name implies it's only used in finance firms. But I think fintech, this whole idea of operationalizing things like automated chatbots that will handle tier 1, tier 2, and possibly tier 3 help desk inquiries and maybe kick you up to the next level when you actually need a human customer support, automated trading routines, All of those types of things, if you think about them being used in the financial services industries, are likely to spread to other industries. For instance, when I call any help desk nowadays, like as not, I'm going to get a computer, and that computer is going to use natural language processing to try to decide exactly what type of question I've got, what type of issue I'm having, whether it can handle it, and whether it should go ahead and sort of hand me off to an actual human. So I think it's safe to say analytics is still a growing field, particularly when you talk about mid and small size businesses. They're still trying to get a handle on analytics. But the large firms, they've sort of got analytics handled, and now they're looking at operationalizing. In a sense, you could think of fintech is once you know what the metrics are, and once you know what you're looking for, it doesn't matter whether you're having a computer engage with somebody asking for help, or having a computer monitor the markets and make trading decisions based upon mispricings between, let's say, the underlying stocks and a mutual fund or something along those lines. But once you know what the metrics are, once you know what the type of analytics are, and once you know what the action should be, then it's a case of basically advancing analytics and turning around and operationalizing it through fintech. So I think fintech will be spreading to lots of other industries. And, we could start talking about marketing tech, we could start talking about health tech, but it's going to be the same type of things that we're seeing in the fintech sphere.
Okay, so in terms of manpower and skill, so are you telling us that you're going to need a lot more people in the data analytic fields than you would them in fintech fields, because the machine will kind of take over most of the jobs? I mean, most of the, not the job, but most of the processing, but you need a lot more people ahead, because I've got students that have gone into, data analytics using Python and doing some incredible amount of work. But you're right, they don't develop a product, right? It's not really product oriented, it's analytically oriented. So you're telling me that I need a lot more people in data analytics than I would need in fintech, or do I need different kind of people?
Well, it's definitely, first of all, it's definitely different kind of people. If you think about, one of the discussions that you and I've had, and sometimes we've had actually through our dean, is what's the best language for the computationally oriented programs we've got here? I teach in the business analytics core for the undergrads, and so I use R. And the decision was made because of various reasons. You teach fintech, but R is not the language for fintech. Really, Python is the language for fintech. And it boils down to the fact that, well, R is an interpreted language. That is, it's slower, but by being interpreted, sort of the computer help can jump in at any moment. It can and sort of monitor and prompt the user as they're typing things into an IDE where to go. Whereas if you're going to operationalize stuff, then you'd like something where you can set up a program, have it run independently, maybe as a cron job on a Linux server, constantly watching, constantly ready to act on behalf of the human. And for that, R is not suitable. You need Python, or in the more extreme cases, if you go to the very large firms, they want a speed advantage, so they're actually programming in C++ rather than Python. So you definitely need people with different types of skills. I think it's safe to say, though, that, even when you've got fintech situations, some human right now has to be responsible for determining whether the environment, the metrics, and or the reaction that you want to various metrics has changed or not. Most of fintech that we've seen up to date has involved a human sitting down and figuring out the rules and then coding those rules so the computer can react quickly or cheaply to situations. We haven't really obviously seen true AI, although there was a furor a couple of months ago about, I forget which large tech company was saying, hey, we think that we actually have somebody that could pass the Turing test, but we're not there yet. And so we don't really have artificial intelligences that can determine what the relationships are and then act on them themselves. We're still at the point of humans having to determine what the relationship vis-a-vis various metrics and opportunities and what we want to happen, and then coding it. So I think it's safe to say that there's sort of a whole spectrum of possible career choices, whole spectrum of needs in terms of skill sets. You need people that are going to do analytics, where the idea is that humans are always going to be looking at the results of that analytics. They're looking at the graph, they're looking at the metrics, and they're making decisions on them. But you've also got people that are doing analytics with an eye towards, okay, it looks like this is a fairly stable relationship. How now do I operationalize it? So there you'll need people that can do the analytics and are using whatever tools, or even, in Python using Matplotlib and stuff like that, but then turn it around into operational code. And then you have people that'll be working purely in the support and development of operationalized code for fintech situations. That is, everybody has pretty much accepted that the relationship in this particular area is known. It's not going to change. Now it's just a matter of tweaking it, trying to make it faster, and so forth. Case in point, back around the turn of the century, I did a large consulting job for Chase Manhattan Bank, and they were in the process of consolidating their foreign exchange and derivative desk. Long story short, they decided to go with common exposure measurements between the two types of deals and common limits, credit limits, with counterparties for the two types of deals. At that time, the state of the art was, it took almost, I think it was close to maybe 7+ hours to sit down and calculate the total portfolio exposure for every counterparty that the bank had. So what that meant is they did it 3 times a day, and they had 3 international chief credit officers that they handed off responsibility for doing these activities every 8 hours to each other. I haven't been involved in a similar situation since, but I think now it'd be safe to say that large banks are probably not batching this type of stuff 3 times a day. They're probably doing the best they can to get as close to real-time analysis of impact on portfolio effects when they do a new foreign exchange or a new derivatives deal with a counterparty, and sort of trying to be as close to continuous reassessment of their risk exposure as they can. So, but the point here is that illustrates the fact that as technologies increase, as our understanding of the markets increase, as the markets change, we're going to need people at the sort of fintech end of the spectrum constantly developing, optimizing, and redeveloping and re-optimizing those tools based upon current situation and current capabilities.
So therefore, what are the skills? If someone is saying, well, am I a data analytical person? Am I a fintech person? What do you see every day? What kind of profile do you see that goes into either field?
Well, I think on the analytics side, you need to know how to code. You need to know how to script, but it's more a matter of interpreting it and sort of making a finished product that a human is going to appreciate and be able to use. So it's more or less an art form. You really do need a mixture of knowing how to get the data, how to clean the data, organize the data, and then visualize and report off the data, but in a way that a human can digest it. So if you're more sort of, I like tech stuff, but I really want to work with people, that's the analytics side. In terms of optimizing code and in terms of making it run as fast and efficiently as possible, if you're more into like a conventional programming mindset, then you're on the fintech end of the spectrum. Because at the very end of that, you've got, if I can work the internet connections and the hits against the database and speed those up enough so that I can actually beat the market, I can come to the point where I not only get the data, but analyze the data and then act on it faster than, the typical small investor who's a human sitting there. Oh yeah, I noticed this. But it's going to take me a couple of seconds to submit a trade and everything. There, it's about optimizing code. So I think it depends on sort of where a person's wheelhouse is. If they're more interested in working with people, but they like tech stuff, if you will, then they're going to be on the analytics end of the spectrum. If you're more of the conventional programming mindset in terms of it's all about optimization, it's all about getting the code to run as quickly as possible, and you're not really going to be quite as focused on working with humans directly, then it's more on the fintech end of the spectrum.
It's interesting because most of my students, although I have some of them that I ended up in software development and I guess which would fintech, most of them end up really in data science and data analytics. In fact, that's their title, where they They enjoy the programming, they enjoy the coding, but they don't want to be a programmer.
Mhm.
They want to use it because nowadays I think everybody kind of know how to code. But they'll tend to that. Now, when you started our conversation, you mentioned data science because there are lots of programs out there, and there's actually a data science program as well. How does it? So, if data science is that data is a mix of both, is that what you see? What you mean by data
I
science? Is
think
it
data science would encompass both, but it also has areas that are not included conventionally in either fintech or data analytics. One of the areas, for instance, would be the question of hardware infrastructure. We've heard the term lately, data engineer, thrown around. And that's used a lot of times when somebody is looking at a position where they're going to be optimizing access to data. You know, the question is how much recent versus how much historical data do you need access to? What database format do you use? What type of data are you storing? How quickly can you access it? But there's also questions in terms of what type of sort of system should the fintech and the analytics people, who are more or less system users, but what type of system should they be provided? What kind of environment can we give them so that we can terribly speed things up? Case in point, when I worked at a research-oriented school before, I was the director for research computing. And I had a statistician working for me that was working on a very large natural language processing problem. And it dealt with historical data from a number of years from thousands of different sources. And so he coded it to run on the supercomputing network that we had. And he came to me and he said, Troy, I've got it ready to go. I've sampled it on a smaller part of the data. And I think if I run the whole thing, it's going to take like 57 weeks to run. He said, there has to be a better way. Well, luckily, one of the things that I realized is that the delay or the lag factor there was the fact that storage was at one physical location in Massachusetts, compute was another physical location. So he was getting a lot of latency induced by basically loading out of storage into memory and processing it. So what we did is we actually went out and bought him an Alienware gaming computer that had a really, really fast and large capacity RAM video card. And luckily, he knew enough about it to use TensorFlow and those packages. But he was basically able to very quickly rewrite his code to take advantage of the massively parallel processing capabilities of the, I forget how many thousands of CUDA cores he had in the GPU. I want to say it was like 4,096. It might have been more than that. But basically, he was able to process on a machine where memory and compute capacity and storage were all running off of a very, very fast bus designed for a gaming computer. So he was able to cut it from something like 57 weeks down to a week in terms of processing the same type of data. But the point is, he was an end user. End users a lot of times are not familiar with, you know, what limitations are being imposed by the hardware that I'm operating on. And they probably shouldn't have to worry about it, but there are people whose job it is to worry about it. You know, can you basically get a increase in economies of scale up to an order of magnitude by switching over to a different type of processing? Or can you get cheaper, compute? One of the big changes we're seeing now is a lot of analysis, a lot of analytics are being done on cloud computing resources. And what does that mean in terms of accessing them, in terms of cost effectiveness, in terms of ubiquitousness, and so forth? So I think infrastructure is one consideration. You could dive down and say, well, even network construction and analysis in terms of optimization for large scale analytics and or fintech operations is going to be crucial. And I'm sure there's people out there that all they do is they fine tune the network and they fine tune the access and make sure that the network infrastructure is optimized for the types of analytics and or operationalization that their company's doing.
So what about, because you mentioned some of the assignment that you had in banking, and I'm seeing what's going on with students nowadays and kind of jobs they're getting. Um, but what's going to happen to your typical financial analyst? Can they not be a data scientist or in fintechs? Can they still remain in a purely analytical field without having to use programming language? Are they safe? I mean, when I started, right, we use Excel, and we got away with that for the longest time. Maybe we use VBA, but we never programmed or used Python, even though these things existed at that time. The C++ were reserved for the programs. What's going on with this old school? Is it safe? Was it in danger? What's going on with these students?
I think there'll be a demand for conventional Excel-based analysis for a while. And I think we've seen Microsoft enhance the capabilities of Excel through their BI tools and so forth. Having said that, a couple of points that I'll make. One of the things that's driving sort of the safety of conventional financial analysis is the fact that firms are only required to report on a quarterly basis. So to the extent that, changes in their situation happen continually, changes in their finances happen continually, the impact of the market, the supply chain and issues, to the extent that we stick with sort of quarterly reporting and everybody only sort of gets an information reveal once a quarter, you can probably stay in Excel and do some of the analysis that you've always been doing. However, even if we stick with quarterly and or yearly information reveals, you also have to understand that it's not just the internal information that drives the profitability of firms. Many firms that I've worked with have been in the process of not just taking the data that they have in their own systems, but leveraging outside data. I worked for a large insurance company in San Antonio that deals with current and former military called USAA. And one of the things they were looking at increasing the efficacy of their forecasting models for their insurance products was bringing in real world outside data on a continual basis, such as temperature extremes, such as ongoing forecasts for number of hurricane-sized storms in the Gulf Coast, because they sold flood insurance, they sold hurricane insurance, they sold you name it, lots of types of insurance that was affected by weather extremes, global warming, and so forth. So I think to the extent that financial analysts are at some point, even if they're sticking with sort of quarterly release data, there's other data sources. There are, for instance, you could conventionally farm tweets, and you could see, one of the things I've always wanted to do is to see everybody that walks out of a Best Buy. We've seen research where researchers have followed the analysts that tweet about Best Buy, and to see whether or not you can get some insight. You can sort of front run what their next buy sell recommendation on Best Buy is going to be, and so forth. But one of the things that we haven't seen, but I think that that's evocative of what we will start seeing, is people start following all the customers that walk out of Best Buy. Anybody that tweets anything about Best Buy, what's the sort of average emotional latency of the tweets about Best Buy? And then what's the average emotional latency of the tweets about every single firm that's out there? That information is not going to be dropped out in quarterly chunks. It's going to come out in a continuous stream. The other thing to remember too, Microsoft expanded the capabilities of Excel. I want to say it was around Excel 2010. They went from having the capability of having something like 64 or 65,000 rows. So now they can have 1,048,000 rows. That's not likely to get increased anytime soon. And even if it does, let's suppose they increased it another order of magnitude. Wow, 10 million rows. I go and get New York City taxi cab data for my classes all the time. And 1 month in 2017 worth of rides is 9.6 million rows. And so if you want to do seasonal analysis, think about 12 times 9.6 million. It isn't going to fit in an Excel spreadsheet. So I think the short answer is eventually you got to up your game. The long answer, or the more detailed answer, is I think there'll be a place for people that can, really work with Excel. They know Visual Basic for applications. They can do pivot tables. They can do VLOOKUP to bring things in from other tables. But I think that increasingly, particularly over the next decade, it's not going to be enough just to be really good at that. I think you're going to have to be able to use other data sources, larger data sources, continually updated data sources. And for that, you need better tools. You need Python, you need R, you need some type of analytics suite, if you will.
Okay, we're not there yet, but we are on our way. I hear you, and that's something that I always talk to my student about. And I mean, my program, anyone we're working with right now require Python before you even start anything. If you don't know Python, you really can't get anywhere. But that's a graduate level. At the undergraduate, okay, for the time being, and they still could, still could get a job. But I could see, I mean, it's on its way. Great. So, Troy, thank you very much for your time. I think this was helpful. This should help anybody listening to get the difference between data science, data analytical, fintech, and more importantly, what's going to happen next. But it's changing quite a bit. What did I see? In fact, I think it's you who told me that 90% of the data is created every 3 years. I mean,
Yep.
It's humongous. People don't realize. At some point, you have to wonder, what do they, where does YouTube stores all of its videos and tweets, and it's humongous.
So one of the things that's funny is that I started our business analytics undergraduate courses about 3 years ago. And back then, my go-to example was 1 month of New York City taxi cab data from, I think it's June of 2017. And at the time, I noted that, 1 month's worth of data there is, I think it was 800 meg. That is, it was just about the size of a CD. Now in my classes, I have students clone a repository from GitHub for the New York Times, where they track COVID data. And, there, it's not just what you see, but it's all those backup copies of the updated data from yesterday and the previous day. They update this data every single day, multiple times a day since COVID started. And I was pointing out to my students just last week that now, even though it doesn't look that big when you look at it with Excel or something, but when you actually look at the size of all the files involved, just in a data repo for COVID-19, it's 7.4 gigs. So in the course of 3 years, we've gone from me using as my typical data set something the size of a music CD to now something the size of a double-sided DVD that has a movie on it. And that's an increase of, well, an order of magnitude in 3 years. And, I'm just catching a very slim sort of glimpse, if you will, of the data ecosystem there. But yeah, I would say that data is accumulating faster than we can hope to process it. And so we're going to have to use the fastest, best tools that are capable of dealing with it.
Thank you, Troy, and see you next time.
My pleasure. Take care.